Good evening to all of you. I'm Muskan Khan and this is group number 26 and my project partner is Shweta Patil and our topic number is number 3. I'm going to present the working and Shweta will demonstrate the code further. Now let us start with the brief introduction of our project. So these are the outlines and me and Shweta will dictate one by one accordingly. The objective of our project is to predict or to return the best route prediction from source to destination, provided by various matrices such as distance, traffic, vehicle type, road type, safety level, number of diversions, and network communication, etc. And in a roadmap, the system shall identify the optimal route between the source and the destination. So we have used the reinforcement learning of machine learning, and reinforcement means to establish and encourage a pattern of behavior. Let's take an example. Suppose you have dropped to an island. Initially, what will you do? You will panic and confuse what to do, how to live and how to get food and all this. But after some time, you have to adapt and you must learn how to live on that planet, learn what to eat and what not to eat. So basically you are following the hit and trial concept, and you the only way to live is to learn from experience, and this is exactly what reinforcement learning is. So here the reinforced agent decides what actions to be taken in order to perform the given task, and in the absence of training datasets, it is bound to learn from its experience itself. And these are the key areas, that is agent, environment, action, reward, and state. And I'll dictate one by one in the next slide. So this is the graph, or we can say the roadmap, which we have implemented in our project, which consists of 14 locations from a location N1, L1 to L14. And the previous four key areas together establishes the foundation of reinforcement learning. Now the task is to enable the robot so that they can find the optimal route on their own. Here the first first key is agent, and that is in our project. Agent is a robot. The environment is the roadmap from source or location L1 to destination, that is location L14. The state is the location in which the particular robot is present at a particular instant. So suppose a robot is at location L11, that is Sagar. So this is the state of a robot. And in our example, the actions will be the direct location that robot can call from the particular location. Suppose the location is at location L1, that is at Indore. So the direct location will be L2, L3. Now let's execute the source code of our project without any further delay. So I'm executing it on the Jupyter notebook. So as here we can see that in line 15, while using the get optimal route function, we get the, or we have printed the route which is from Indore to Jabalpur, which is the best route. And likewise the other routes also. Now let's see the code. So here we have imported some Python libraries. So first is the sys, which is a module which provides the access to some variable used and maintained by the interpreter. SciPy is the library that uses the NumPy for more mathematical function like linear algebra and integration. NumPy is the open source numerical Python library that contains the multidimensional array and matrix data structure. Matplotlib is used to plot the graphs, and last one is the pandas. So it is the manipulation tool built on NumPy packages, and its e-data structure are called data frames. So in line 3 we have initialized two factors, that is gamma discounting factor and alpha learning factor. So the value of gamma lies between 0 and 1. The smaller the gamma and the larger is the discounting value. But if the gamma value is 1, then it means our agent will going to explore the destinations which are nearer to them. And if the gamma value is lesser than that, then the agent will not going to explore the nearer destinations or nearer locations. Likewise, the learning rate is too large, then it can cause the model to converge too quickly. And if it is too small, then it can cause the process to get stuck. So we have to be aware while choosing the or giving the initializing parameters. Now here in line 4 we have given 14 states or created 14 states, and accordingly we have created 14 actions. As the action cannot be created in the form of string, so we have created or given them integer values. Now we have created a distance matrix, which is a reward matrix, and if the way is direct from source to destination, then we have rewarded with the value 1, otherwise we have rewarded with the value 0 to the indirect way. So this is the graph, and if we can move from Rajgarh to Bhopal, then we are moving through Devas, so it is the indirect way. And if we are moving from Indore to Baitul, then it is the direct way. Now moving ahead with the second matrix, that is road type matrix. So here we have calculated or created matrix on the basis of national highways. If there is a national highway, then we have rewarded with the value 1, otherwise 0. Third one is safety, which has created on the basis of safety level. Fourth is the traffic reward matrix, that is if the traffic is high, then we have rewarded 0, and if the traffic is low, then we have rewarded 1. Next one is network availability reward matrix. So on the basis of availability of network, we have created a matrix. That means if the network is good, then we have rewarded 1, otherwise uh, we have rewarded 0. That means in case of bad network availability. And the last reward matrix is divergence. So divergence, if there are more than 2 or equal to 2 divergent, then we have rewarded value 1, or
I'm Shweta Patil. Now I'm going to explain how we create the final reward matrix and the function that we are using to find the optimal route between source to destination. So for creating the final reward matrix, firstly we are creating three matrices, reward 1, reward 2 and ARR, and initialize its values to 0. For finding the optimal route, we have conditions like distance, road type, traffic, network diversion, and safety. So first we are taking distance and road type, and we are applying logical OR in it. Like we have condition, if the road type is good but distance is large, then we are selecting that road. If distance is small but road type is not good, then we are selecting that road. And if both are good, then we are selecting that path. And finally we are putting its result in reward 1 matrix. Likewise we are doing for network diversion and traffic and putting its result in reward 2 matrix. And for preparing final reward matrix, we are performing logical AND in but for safety, result of reward 1 and result of reward 2. Here we don't want to compromise with the result of reward 1, reward 2 and safety. We only want best, that's why we applied logical AND. Now this ARR is our final reward matrix, but its content is in form of true and false, and our reward matrix need values in form of 1 and 0. So for this we create another matrix reward whose data type is int, and we initialize its values to 0. Now using this loop we are converting those true and false value in 1 and 0 form, and here is our final reward matrix. Um, Here we are doing inverse mapping from state to location. It's a mapping of state back to its original location. For finding the optimal route, get optimal route function will work. It takes the start location and end location as arguments. So first we start by copying our reward matrix to a new matrix. Then we give end location a state using location to state mapping, and now we set highest reward to our end state. Now we create a queue matrix and initialize all its values to 0. For updating the values of queue matrix, we use for loop. We start with picking up a random state using np.random.random function. Now to traverse through the neighbor locations in a same maze, we iterate through the new reward matrix and get the actions which are greater than 0, and we put all those actions in playable action array. Now we pick a random action that will lead us to the next state from a list of playable actions. Then we calculate the temporal difference, which takes the reward plus gamma into q value of next state and maximum of q value of next state and minus q value of current state. Then we update the q value using Boltzmann equation. After updating our Q matrix, now we initialize our optimal route with start location. Till now we don't know about the next location, so we initialize our next location to the start location. And we also, here we don't know the exact number of iterations we needed to reach the final location. So for this we are using while loop. We first fetch the starting state, then we fetch the highest q value pertaining to starting state. Now we got the index of next state. So we are doing here using inverse mapping state to location function. We are giving this next state its location. We are mapping it with its location. Then we finally append that location to the route, and this loop will work till next location is equal to end location, and finally it will return a route. And now as you see, if I print get optimal route from source to destination, it will print its optimal path. Thank you. Now this is our code in Eclipse IDE. And here we are finding optimal route from Rajgarh to Narsinghpur, and when we run it, This gave us maximal optimal route from Rajgarh to Narsingpur and from Batul to Vidisha. This is the optimal route from Batul to Vidisha. Thank you.